Hello friends, welcome to your own channel Online Physics. Here we provide you solutions of your problems and we will also discuss various concepts of physics. So subscribe this channel to getting more videos on physics. And this video is about the part 1 of graphical analysis, in which we are going to discuss about how to convert speed time graph to distance time graph and speed time graph to acceleration time graph, which is very important for part A of CSIR net. So after understanding the whole concept, at last we will discuss 3 problems of CSIR net JRF, in which 2 problems are from June 2015 and 1 problem is from June 2016. So are you ready? Let's begin. So here, to convert speed time graph to distance time graph, the first question is arise that how you can relate speed time to distance time. So here the answer is gradient. That's mean how one variable change with respect to other. So here if you know that how speed changes with time, you can easily relate that how distance changes with time. So here you have to know the 5 types of gradients. So the first one is decreasing gradient. So here this curve shows the decreasing gradient. So the next is increasing gradient, which is like this one. And the third is positive constant gradient. That means the rate of change is constant in positive direction. So here the next one is zero gradient. That means no change. So here the last one is negative constant gradient, which tells you that the rate of change is constant in negative direction. So here these 5 things are very important to convert the graph of speed time to distance time. And if you remember these 5 things, it's very easy to convert the graph. So let's look how we apply these things. So here in speed time graph, first line indicates increasing speed. That's mean increasing gradient. So to convert in distance time, we have to draw a curve which indicates increasing gradients. So this curve indicates increasing gradient. So let's come to the second case. So in the second case, you can see that this line indicates the positive constant gradient. So to convert in distance time graph, let's draw a line which indicates positive constant gradient. So now let's come to the third. So here the third one indicates the decreasing gradient. So to convert in distance time, we have this curve for the decreasing gradient. So this is the case of conversion of speed time graph to distance time graph. So now let's come to the second case, which is speed time to acceleration time. So let's find out the relation of speed time graph to acceleration time graph. And you can also say that how you can get the information about acceleration time graph from speed time graph. So we know that for constant speed, the acceleration is also constant. So the first case is of positive constant gradient. So here this line shows the positive constant acceleration. So here the next case is of constant speed. So as we know that for constant speed, the acceleration is 0. So here this line indicates the 0 acceleration. So now the next case is of decreasing speed. So that means negative constant gradient. So for the negative constant gradient, we have acceleration in negative value. So here this line shows the negative constant gradient for the acceleration. So I hope you understand all these things. Now let's come to an example. So here the first case is conversion of speed time graph to distance time graph. So here this is the speed time graph which we have to convert into distance time graph. Now here up to this point we have a line of decreasing gradient. So now in the distance time graph, draw the curve which indicates the decreasing gradient. So now this curve indicates the decreasing gradients. So here up to this point we have a positive constant gradient. So for positive constant gradient we have this straight line for the distance time graph. So here the next part indicates the positive increasing gradient. So let's draw the curve for the positive constant gradient for distance time graph. So this is the way how to convert speed time graph to distance time graph. So here the next case is conversion of speed time graph to acceleration time graph. So here we have same speed time graph and we have to convert it into acceleration time graph. So here we know that for constant speed we have a constant acceleration, whatever it is increasing, decreasing or zero. If speed is increasing we have constant positive acceleration, and if it is zero we have zero acceleration, and if speed is decreasing constantly that means we have negative constant gradient. So if you know all these things, you can easily convert speed time into acceleration time graph. So up to this curve we have decreasing gradient, that means this line shows the negative constant gradient. And for the next part we have zero constant gradient. So this is for zero constant gradient. And the next part is of increasing constant gradient. So here this line shows the positive constant gradient. So this is the way how to convert speed time graph to acceleration time graph. So now let's discuss the previous year problems of CSR net on this topic. So here the first one is from December 2015. So the question is, a vessel is partially filled with water. More water is added to it at a rate directly proportional to time. Which of the following graphs depicts correctly the variation of total volume V of water with time? Now here you should note one thing, that the vessel is partially filled with water. That means vessel is not empty. So here the gradient is not start from 0. So you can eliminate first and fourth option. Now we have left with second and third option. Now to identify the correct answer, the next thing is water is added to it at a rate directly proportional to time. So it shows the increasing gradient. So now I hope you already find the correct option. And if you find, then congratulations to you. So here in the second option, the curve shows the increasing gradient. So that means second option is our correct answer. Now here the second question is also from December 2015. The question is, a bird leaves its nest and flies away. Its distance x from the nest is plotted as a function of time. Which of the following plots cannot be right? So this is the question of common sense. Now here you have to choose the incorrect option. So let's check the options. Now in the first option you have a constant positive gradient. So it may be possible that bird flies constantly upward. Now in the second option, the first half of the graph shows the increasing gradient and the next half shows the decreasing gradient. And it can also be a possible case for this situation. Now let's come to the third. Now here in the third option we have no any sequence of increasing or decreasing gradient. So it will not possible case for this situation. Now in the option 4 you can see that it show a proper sequence of increasing and decreasing gradient. So here option 3 is incorrect case for this situation. And this is our correct option according to this question. Now let's come to the next question, which is from December 2016. The question is, which of the following graphs correctly shows the speed and the corresponding distance covered by an object moving along a straight line? So now let's check out which is correct option. Here dotted line shows the speed and solid line shows the distance. So now in the first option, the curve which shows speed are in decreasing gradient, but the distance line shows the increasing gradients. So this is not correct option. And in the second option we have constant increasing gradient, and for this we have a horizontal line for distance. So this is also not correct option. Now in the option third, the speed curve is first increasing, then constant, and after that it going to decrease. And for distance curve it also shows first increasing gradient then constant. So this is a possible case. So let's check the fourth option. Now in the fourth option the speed curve is constant gradient, but the curve for distance not showing the constant gradient. So here the third option is correct answer. So now thanks for watching this video. Subscribe for learning and share for helping. Please share this video to all your friends so they will also get benefit from this. And the last thing is, please don't forget to like this video. Thank you.